I told you on Monday the definition of amplitude. Okay, I can give you two definitions. First one, it is the height of the crest. This is called a crest. So the height of it is the amplitude. The amplitude is always positive. Okay? It is always positive. Amplitude is never negative. Okay? That's not only in maths, including in physics as well. Amplitude is always positive. It's a distance, right? Amplitude is also the depth of a trough. This is called a trough. Furthermore, amplitude is also the positive of the coefficient of sine x. Okay, what's the coefficient of sine x? 1. That 1 there is your amplitude. Sometimes you're going to have a minus, say, whereby the coefficient of sine x will be -1. But when you're asked to determine the amplitude, it will be the positive value, or a positive, or rather you can say it will be the magnitude of -1 to be a positive 1. So amplitude is always positive. So the amplitude here is going to be 1 unit. All right? Then we can have what's called the period. I'm going to define it on the next page. This is 360 degrees. Right? By period, we are saying how long does it take for the graph to start repeating itself? Okay? So the number of degrees that a graph takes to repeat itself is called the period. Okay? In maths, as I told you on Monday, we measure our period in degrees. So the graph starts here at the origin, goes up, then it goes down, then it goes up again, up to there. From this point here, if you are going towards values that are greater than 360 degrees, the graph will start to repeat itself again, and it will carry on up to infinity. Also, okay, it's just that in this grade, grade 10, we don't talk about negative angles. On the left-hand side of the x-axis, that is the negative side, it will start to repeat itself as well, going that way, like a wave, right? So, the sine graph, that is y equal to sine x, repeats itself after every 360 degrees. Therefore, the period is 360 degrees. In fact, in grade 10, whenever you see any graph of sine, any graph, okay, including the one that I will talk about later, that results from this one here, the period is always 360 degrees. It doesn't change in this grade. Right? Then the domain. Now your domain, remember to write domain, you need to identify the minimum value of x. The domain is the set of all the x values. You need to determine the minimum value and the maximum value first. Okay? So our minimum here is going to be the value of x at the origin, which will be 0 degrees. So this will be x is an element. We are starting from 0 degrees up to the maximum, which is 360 degrees. Okay, so that will be the domain of this graph. Then the range. The range is the set of all the y values. So we need the minimum value of y and the maximum. The minimum value, you get it at the minimum turning point. This point here is called a turning point. Okay? That point is called a turning point. It is a point where the values of y, okay, will change. In actual fact, we can say where the gradient you want, or you can say the values of y are changing from decreasing to starting to be increasing again. So from this point there, the values of y are decreasing. When you get to the turning point, they stop decreasing. So it's like a stationary point. Then they start to increase again. All right? So the minimum value there it's -1. So y will be an element of, you're starting from -1. The maximum is the value of y at the turning point, at the maximum turning point. Okay? I think I need to define to just remind you that maybe let's add this on the graph. Right, this point here, that point is called a maximum turning point. Maximum turning point. And this point is called minimum turning point. Right. Okay, so we'll stop there for now. Let's move on to the definition of amplitude and the definition of period. Okay, so let me write a definition. Start with amplitude. Okay, is the height of a crest or is the depth of a trough. A trough, right? Amplitude is a distance. Okay, amplitude is a distance, therefore it's always positive. Therefore it's always positive. Okay, let me underline this. That's very important. Well, if you get a question in a test, you're given a graph, and then you are asked to determine the amplitude, but then you write a negative answer. That's important. Okay? Also, there's a formula which I'm going to give you now to calculate it. Okay, formula. That formula will make things easy because later on you're going to find that the coefficient of sine x is going to be more than 1. Sometimes it can be less than 1. Therefore, the formula to calculate amplitude is this. Up to metric, this formula works, and beyond. Y maximum minus y minimum all over 2. So you can use that formula to calculate amplitude. So let me write here 1, and then that's amplitude. Okay. So in actual fact, there are probably maybe, I would say maybe 4 ways of finding the amplitude. If you know the equation of the graph, you can determine the amplitude by the positive coefficient of sine x. Okay? Or you can also determine if the graph is drawn by determining the height of the crest or the depth of a trough. You can also determine by finding the maximum value of y and the minimum value of y. Then you subtract the minimum from the maximum, you divide the answer by 2. So what that means is, for this graph here, the minimum is -1, maximum is 1. So 1 minus -1 all over 2 will give you a 1. Okay? Right? Okay, I'm going to use it later on when I do more examples. So that's amplitude. Then period. Let me write it down. Period. Yeah, I'll say refers to how long the graph repeats itself. Refers to how long the graph will start to repeat itself. Okay, unfortunately, in this grade, your period for any sine graph will always be 360. Okay, so period refers to how long it takes for the graph to start repeating itself. And I've explained that part. Right. Then let's move on to the general equation. The general equation of sine graphs. So let's write a new heading. General equation of sine graphs. General equation of sine graph. Okay, if you look here, I have written sine in terms of the full word for sine. Okay, so the general equation is right. Allow me for now. Let me use both function notation. Okay, I'm gonna start using function notation now. So I'll say it's y equal to f of x equal to a times sine x plus q. Okay, I've written y equal to f of x, but later on you're going to find that I'll just use y only, or I can use f of x only. Okay, and always remember that y is equivalent to f of x. They are the same. It's only that f of x is a new type of notation which we're not used to in the past, which is called function notation. And that notation is the most common one used in mathematics in the FET phase when you are dealing with graphs or when you are dealing with functions. Okay? So you need to make sure that you remember this. Right? Let's define now what that A is. Where A is a value. Okay, let me just put that a point. A is a value that determines the amplitude of the graph. Okay, please, A is not the amplitude, but it is a value that you can use to determine the amplitude. Okay, because A can be positive or negative. Okay, so the next point for that A there, I'll say amplitude is the positive value of A. Okay, amplitude is the positive value of A. Okay, please take note that this A here it's referring to this. Okay. Okay. If A is negative, it means your amplitude will be the positive value of that negative value. Or we can call it the magnitude of A. Right? Then Q now. Let's talk about Q. So I've defined what A is. Now Q is a value which determines the vertical shift of the graph. Okay, let me go to the next page. Can I carry on? Q is a value that determines the vertical shift of the graph. Okay, now we have got two scenarios when it comes to Q now. If Q is greater than 0, the graph moves up by Q units. The graph moves upwards by Q units. Okay? Then, if Q is less than 0, the graph moves downwards by Q units. Okay. Unfortunately, in grade 10, we only talk about vertical shift. Okay, no horizontal shift. All right. Now, the good thing is everything that I've mentioned here with regard to A and Q, the definition of amplitude, definition of period, it also applies to the graph of sine. Sorry, of cosine then. It also applies to the graph of cosine. So when I start talking about the graph of cosine later on, I won't need to repeat this. I'll just remind you that everything I said with regard to the value, to the graph of sine is also applicable to the graph of cosine. Okay, the two are related. All right, so let's start with a case where Q is 0, but A is no longer equal to 1. Okay, let's start with a case where Q is equal to 0, which means there's no vertical shift, right? But the value of A is no longer 1. For the basic graph, just to remind everyone that when I'm saying basic graph, I'm talking about this graph. This is the graph that we are going to play around with. We are going to move it up or down. We are going to stretch it so that the amplitude cannot be equal to 1. It can be 2, 3, and so on. All right? We can also reflect this graph about the x-axis so that this maximum turning point becomes the minimum turning point becomes the maximum. Right? So we'll deal with that later, but we are going to be playing around with this. So when you see the graph of sine, first thing that must come into your head is the basic graph. Right? So let's do an example now on sketch. Example. All right, I'm going to show you how to use a calculator, okay, to do a table of values. So take out your calculator. I hope you brought your calculator to school. Because whenever you come to a math lesson, you're supposed to have a calculator. Right. It's one of the tools that you can't forget about at home. All right, so allow me, for now, I'm going to use function notation. So let's sketch. Okay, let me say my f of x power 2. Well, let's start with 2 sine x. Okay, let's start with 2 sine x. Right, now 2 sine x is related to y equal to sine x. Okay, now the thing is, I'm going to ask you later to sketch the basic graph on the same system of x's after sketching 2 sine x. So what I want you to do, pay attention carefully. So you go to mode, start afresh. Right, first thing, you click on mode. Now, depending on the calculator, it give you many functions. Some of them give you 3, others give you 5. So you go to table, that's number 7. Then your calculator will say f of x equal to. That f of x is y. Okay, f of x is equal to what? Y. So my equation is f of x equal to 2 sine x. I'll put 2, right? Then sine, make sure you look here. You're following that. It's better. Whilst I'm doing it, you must also be doing it as well. Okay, because this is practical. Then if you want to put x, you click on alpha, then close the bracket, where there is x there, then you close the bracket. Okay, I'm going to repeat this part. Okay, I'm going to repeat it. So first thing, you click on 2, because that's the coefficient of sine x. Then you click on sine, then alpha. It's written in red for my calculator. I don't know your calculator, what color. Right, so you click on alpha, then you go to the, close the bracket, okay? There is an x in red, which is the second function. That's why you have to click on what? Alpha first, then you press the x. So this one here, right? So I've got my x there, and I close my bracket. So my function has now been entered into the calculator. Then the next thing now, you press equals. Okay? Now my calculator can do a table of values for 2 functions at the same time, which is what this calculator cannot do. That's another shortcoming of the calculators that some of you have. Because in this grade, we may ask you to draw 2 graphs on the same system of axes at the same time. So if you have got this calculator, it means you will do this procedure here 2 times. And time will be what? Will be moving. Right. Now, in this case, since I just want to get a table of values for one function, you click on 0. Make sure you follow what I'm doing, because some learners will end up, when they are on their own at home, they'll say, I can't figure out, but how did Mr. Chonda do it? Do it as I am doing it as well. So if your calculator says g of x equal to, put 0, okay? Then you press equals. Like, when it says start, start means, what is the minimum value of the domain? What's the minimum value of x? Where are you starting from when you are sketching the graph? We are starting from x equal to what? 0. Do you remember when I wrote the domain, I said the domain is from 0 to what? 360. So start is the minimum value of the domain. Minimum value of the domain. So it's 0. So you click 0, then you press equals. Then you need to say end. End is the maximum value of the domain, which is the maximum value of x. For this graph here, because we are in grade 10, we only sketch it between 0 and 360 degrees. So my maximum here will be 360 degrees. Then you press equals again. The calculator will tell you now what is, by step we are saying, if you are going to start from x equal to 0, what is the next value when you are plotting? When you are plotting, what's the next value? You can't make it 360 because the calculator will only give you one value. You won't be able to plot with the graph. So it will be 90 degrees. So we start from 0, then 90, then 180, 270, then 360. Okay? So our step is 90. Then the calculator will give you that table. The table that we normally do manually, or the one that I did manually when I first introduced the sine graph. That table, it can be done with your calculator and within a few seconds. Okay? All right? So now there is no mark allocated for a table of values. If you draw a table, when you're asked to sketch a graph, you draw a table, 0 marks for the table. That's why if you can do it with your calculator quickly, you can get full marks. Because the marks are allocated for sketching the graph. The technique you use to get the values is not important. Okay? So here, that's what we have. Now, on this table here, I only need the first column, that is the x values, and the second column, those are the y values. All right? The third column, I don't need it because I don't have the second equation of a function. Okay? So, as you can see, when x is 0, y is 0, so allow me to just close this, then I'll sketch it. Okay, you are supposed to be using a ruler. Unfortunately, in my case, I don't have a ruler. So I'm going to do it manually. So that's 180 degrees. This will be 90 degrees. That's 270. And this is 360 degrees. Right? Since the value of A is a 2, it means my amplitude is going to be a what? A 2. So let me say here I've got 1 here, then I have 2 there, minus 1, then minus 2. Right. Now I just want you to show, just want to show you something on this table. So when x is 0, y is 0. When x is 90, y is 2. When x is 180, y is 0. Right? When x is equal to 270, y is negative 2. And when x is 360 degrees, y is 0. Right? You can just use the arrows to scroll down. Right, so that's straightforward. So let me plot the points. So when x is 0, that's there. X is 90, y is 2. It will be somewhere there. When x is 180, y is 0. And then when x is 270, y is minus 2. It will be somewhere there. And when x is 360, y is 0. So now I can sketch. When you sketch, no ruler. You don't sketch the graph. The graphs, take all the trigonometric graphs, you don't sketch using a ruler. You have to do it freehand. And it requires a bit of some practice. Okay? I don't like the way it comes out. So let that start. Let me start again. So it's like something like that. It's not really so nice. The shape is okay. I think here it's too sharp. It's more like a straight line. So allow me to redo it again. That's better. It's much better. And it's not perfect, but the shape is okay. Right. So this is the graph of f of x equal to f of x equal to 2 sine x. Right. I'm just going to write some of the properties of it quickly, starting with the amplitude. So our amplitude will be equal to the coefficient of sine x, okay, because the coefficient is positive, so we'll take the positive coefficient, that's a 2. We can also calculate it. If you think you can get confused, you can calculate it, but you need the maximum value and the minimum values of y. The maximum is 2, minimum is 2. So So your amplitude is also equal to y max minus y minimum all over 2. So that will be 2 minus 2 over 2. That will give you 4 over 2, which is 2. Okay, so you can also get the amplitude by a calculation. But if you understood how to get it from the equation, then you don't need a calculation. Okay? Then the period, you don't have to think about this one. It's always 360 degrees in this grade. Then the domain, we have sketched from 0 to 360. So it will be x is an element from 0 degrees to 360 degrees. And the range, it's going to be x, sorry, it's going to be y. Right? The minimum is -2. The maximum is +2. Okay. Right. And I'm going to give you a short exercise now. I want you to sketch the basic graph. Okay, that is y equal to sine x on the same system of x's. So sketch it on the same system of x's quickly. Okay, for y equal to sine x, when y is 90, then you're going to have, so when x is 90, y is going to be 1. This is a common point, right? And then 270, y is going to be -1. So it will be somewhere there. And then that's a common point. So when you sketch it, it will look like this. Okay, then you must label the graph. So this graph here, that's y equal to sine x. Please don't call it f of x equal to sine x, right? When we want to name it, we actually have to call this one here g of x, okay? Because the original graph, it's f of x equal to 2 sine x. Therefore, the second one, it has to be g of x equal to sine x. But it's fine if you write it as y equal to sine x. Okay? But you can't say this is f of x, that's also f of x. No. One of them must be f of x, the other one has to be g of x. Alright? So that's what I'm sure you can see the difference now, that the amplitudes are not the same because the coefficient here is now a 2, the coefficient here is a 1. So it's more like we have stretched the graph of y equal to sine x. We have stretched it by a factor of 1. Right. Okay, let me talk about the graph of cosine. Right. The next lesson, that's when I will introduce the concept of shift, vertical shift. Right, then number two, remember, number 2, we are now sketching y equal to cos x. Okay, y equal to cos x. Right, I'm just gonna draw a table of values just for interest's sake. Okay, so you substitute x equal to 0 there, cos 0 is a 1, cos 90 is 0, and then cos 180, that's minus 1, cos 270, that's 0, cos 360, that's 1. Okay? Right, so let's sketch that graph. So when x is 0, y is 1. When x is 90, y is 0. When x is 180, y is minus 1. When x is 270, y is 0. X is 360. My graph is going to interfere a little bit with my table. Okay. Right, I need to say this. This is actually a little bit important. The graphs of sine and cosine are related. Okay, they have a relationship. The relationship is that the graph of cosine is actually the graph of sine. After moving, if you move the graph of sine x, that is y equal to sine x, by 90 degrees to the left, you get the graph of cosine. So the graph of cosine looks like this. You use freehand. Okay, so that will be the graph of cosine. So this will be y equal to cos x. If you remember the graph of sine, it started from x equal to 0 here, by the origin, then it goes that way. Right. So if you move the graph of sine by 90 degrees to the left, you will get the graph of cosine.
How does it work on criteria of values without a calculation? How does it work?
Okay, that requires knowledge of special angles. Remember, last time I taught you special angles. Remember?
Yes.
Yeah, don't forget I taught you the special angles. But of course, I think 270 we didn't do that, I think. If I'm not mistaken, we can verify that. But 0 degrees I told you what it is. 9 degrees I told you. And now, you see, as you do it more, it becomes natural to you. In my case, I've done it many times, so it's natural now. All right. So if you don't want to do it mentally, you can use your calculator. So you substitute the values of x individually where there is x here. Okay? So if you put them in your calculator, you will get these y values. Okay? If you want, you can verify my y values. Okay, but they are perfect. All right. So I'm just going to repeat this for the last time. The graph of sine, okay, is related to the graph of cosine. Right? If you move this graph here, one in light brown, to the left by 90 degrees, which means this point here, it will move 90 degrees to the left, then it end up being what? In here. This point here moves 90 degrees to the left, it end up being here. This point here moves to the left, it end up being somewhere there. And this point here moves to this point. Then a point for y equal to sine x, which was at 450 degrees, that point moves to what? To the left. It will become your new 360 degrees. I hope you're understanding what I'm saying. So if you shift the graph of y equal to sine x, you get the graph of cosine x. Okay? The good thing is, all the properties that we wrote here, cosine, they are also applicable for cosine. Okay? They're also applicable. So let's just write the properties. I don't have space there. Let me squeeze it here. So the amplitude of this graph is also 1. The coefficient of cos x is a positive 1, therefore amplitude is a 1. Or you can do a calculation. The maximum value of y is a 1, minimum value of y is minus 1. 1 minus minus 1 gives you a 2. 2 divided by 2 will give you 1. Okay? The period is 360 degrees. So the graph of cosine, after every 360 degrees, it starts to repeat itself. Okay? After every 360 degrees. So if I go towards the left-hand side here, it will go down like that, then it carries off, like the sine graph. If I move to the right-hand side, it goes down, then up, then it stops, then it carries off. Okay? So after every 360 degrees, you get a graph like that. Okay, let me just finish this quickly. Right, you can finish it domain and range. Okay, let me just